In math, to prove a statement is true, you need to show that it's true for all examples. What that means is that's why we use all the variables. And if we want to prove something is true, we prove it with variables. And if it's true for variables, that must mean we can substitute any number in for those variables to prove it's a true statement. But what our focus on is going to be counterexamples. And in math, when you want to show that a statement is false, when you want to prove something is false, you don't need to show that it's false for every example. You just need to show that it's false for one example. And that example is called a counterexample. And it says here, counterexample is example used to show that a given statement is false. Basically, to prove a statement is false, you just need to show that it's false one time. So if you look at these examples, it said decide whether the statement is true or false. If it is false, give a counterexample. Just give an example where it's not true. And you have to be careful with these, and you might want to try different examples. And as soon as you find one that doesn't work, you can prove that it's not true, that it's a counterexample. It says the expression, the absolute value of A is always positive. Again, these lines mean absolute value. So, is the absolute value of a number always positive? Well, at first thought, I would think that it's true, because that's what absolute value does. It's the distance from 0 on the number line, and that's always going to be positive. Except there is one number, when you take the absolute value of it, it's not positive. And that number is 0. If you take the absolute value of 0, you get 0. Well, remember, 0 is neither positive nor negative, so that's why this is false. And our direction said, give a counterexample. Well, that's it, this right here. The absolute value of 0 is 0. It's always good, ladies and gentlemen, when you do these type of problems to try 0. Because again, 0 kind of is one of those that falls right in the middle of the number line. It's not positive, it's not negative. And it's also always good to try something that's positive and a number that's negative. Okay? Let's look at the second example here. It says the symbol negative A, or sometimes referred to as the opposite of A, is sometimes equal to the absolute value of A. Pay attention to key words. Sometimes means it doesn't always have to be equal to, but it sometimes can be. Now again, my first thought here is this is a false statement, because when is the opposite of A or the negative A ever going to be equal to the absolute value of A? Well, again, let's try some examples. Let's say I want to make A equal to 2. If I put a 2 in here, I get negative 2. If I put a 2 in here, I get the absolute value of 2, well, which is true? Well, it's not equal there. Let's maybe try a negative number. Let's say A is equal to a negative 3. If I'm going to plug negative 3 in for A, that's negative 3. And a negative 3, or the opposite of a negative 3, is a positive 3. So now let's try it for the absolute value of A. If I plug negative 3 in here, I get the absolute value of a negative 3, which is 3. So now in this case, I've proven that it's not true here. Negative 2 does not equal 2. But here it is true. 3 and 3 are equal to each other. That's why it's good to always try a positive number, a negative number, and 0 too if you can't figure it out by then. But in this case, I'm going to say that it's true. It is sometimes equal to this, just not always. Okay, so just to kind of reiterate, counterexample, you just need to show a counterexample to prove that a statement is false. You just need to come up with one example to say that the statement is false.